Hello everyone, how are you all? Only 10% still now. And result has arrived. I'm fine, thanks for asking. Result has arrived for the retest. How many of you have given? Where are the rest of the people, man? Very few people today. Let's see 2-3 minutes more. Then we will begin today's session. Until then, yeah, I think everything I have set up today. Has the result came out of the retest? Hello, am I audible?
Yes, sir.
When you are supposed to get the retest results? I guess you will get till tomorrow. If you haven't received till today, you might get till tomorrow. Okay, so let's begin today's session. No need to wait anymore. How was it? Whoever has attempted the interviews and retest exam, how was it? Hello. Okay, that's great. Chalo badhiya. Whoever has given the retest, how was it? How was the result? Means how was your exam? Okay, fine. So yesterday, how many of you have gone through the Fibonacci case? What happened, man? How many of you have gone through the Fibonacci case? Is my screen visible to everyone? Is my screen visible to everyone?
Yes, sir.
I think very less people. Why 21 only today? What is the issue? Have they got their results? Those who haven't come. Okay, fine. So let's begin. So see what we were discussing yesterday regarding Fibonacci. If I am to calculate the sixth Fibonacci, what will happen? Tell me that. If I am to calculate sixth Fibonacci using recursion, what steps I will take? Using recursion only, if I am to take the Fibonacci, if I am to calculate the nth Fibonacci, what will happen? First, for calculating the sixth Fibonacci, I will call the fifth Fibonacci. Then for calculating the fifth Fibonacci, I will call the fourth Fibonacci. Now for calculating the fourth Fibonacci, I will call the third Fibonacci. And for calculating the third, I will call the second Fibonacci. Okay. Fine. Now, once this is done, since we have already kept a base case that, okay, the second Fibonacci, we already know that to be 1. This will be returned. Okay. And this function called terminates here. Now another function call comes, that is I need to calculate what is the Fibonacci of 1, and we know that this is 0, and we will return it as it is from Fibonacci of 1, and it will reach the Fibonacci of 3, this function call, right? Fine. Now Fibonacci of 3 has been calculated. It will return what value? What value will be returned to the previous function call? Don't be silent. I think Fibonacci series is clear to all of you. Is it? How we will do that? Using recursion. What will be returned to the f of 4, this function called by f of 3 once it is calculated?
So 1.
1 will be returned. Why 1 will be returned?
So f of 3 is 1. 1 plus 0 is 1.
F of 3 is equal to f of 2 plus f of 1, right? Whatever values will be returned by f of 2 and f of 1, those will be added and combined result will be passed on to the previous function call, right? That is 1. Fine. Now f of 3, f of 4 has successfully calculated f of 3. Now f of 3 will call for what? F of 2, right? Okay, f of 2 is what? 1. We know that already. It will be written as it is. Now, okay, fine. Both the f of 3 and f of 2 for f of 4 has been calculated. Now what it will return to the previous function call? What it will return to the previous function call?
So 2.
Why 2? Apart from you, Shazia, somebody else tell me. Why 2 will be returned to the previous function call? Why there is a sudden pin drop silence? Somebody else, let's try. Why it will return 2 to the previous function call? Tell me that. So nobody will give the answer today to me.
फोर्थ फिबोनाची 2 इसलिए वो वहां पे रिटर्न करेगा.
f of 4 को f of 3 से क्या मिला? 1 मिला. f of 2 से क्या मिला? 1 मिला. तो दोनों को ऐड कर दो. f of 4 क्या है? Will be equal to what? f of 3 plus f of 2, right? f of 3 has returned 1, f of 2 has returned 1. So adding both ones, we will get 2 and 2 will be returned to the previous function call. Is this part clear to all of you? How the function calls are being done and how they are being, what values are being returned? Is this part clear to all of you? Tell me that. Please don't be in a pin drop silence mode. Say in either yes or no.
Yes, sir.
I think either you people are not interested in today's class or something is wrong with this DP topic. What is there? What shall I assume? Okay, fine. 2 has been returned. Now, one thing, let's observe one thing from here. Now, so we are seeing that, okay, this f of 2 has already been calculated once. Why are we calculating it again and again, right? So we decided one thing, that we will keep a table, we will keep an array. And whenever this any particular function, let's say f of 2, okay, whenever its value has been calculated, I will store it. I will store it inside this table. I will store it inside this table, and whenever the requirement will be there, whenever the requirement will again come, I will just check this table and I will return the value directly. Okay, I will return the value directly. This is what we have planned. This is what we have planned, right? Is this point clear to all of you? That yeah, once we are calculating, let's say f of 3 has been calculated, I have stored, okay, whatever value it is returning, 1. Whatever value has been returned by f of 3, I am storing that inside the table. Now say one thing. Now see one thing. Once f of 4 has returned 2, f of 4 has returned 2 to f of 5. it will require f of 3 to be calculated. Am I telling the correct thing? F of 4 for f of 5 is what? F of 5 is equal to f of 4, right? Plus f of 3. So f of 3 needs to be calculated again, right? F of 3 needs to be calculated again. But yeah, if I want to calculate f of 3, for that also I again require calculation of f of 2 and f of 1. Am I correct? These function calls will again needs to be done. Again needs to be separately done so that I get the value of f of 3 again. So to avoid these function calls, what I have done, once previously I have seen that, okay, f of 3 was calculated previously and I have stored its value inside the table. So I will take this value, okay, I will check the table that, okay, whether this value is present inside the table or not. If it is present, no need to call these two functions again. Just return whatever value is there inside the table to the previous function call. That is 1. No need to recall these two functions. Avoid recalling these two functions. And once I am done that, f of 4 has written, f of 4 has been returned 2, f of 3 has returned 1, right? So both has been returned. It will return 3 to the previous function call. Now tell me what will happen based upon whatever we have discussed. Now tell me, once f of 5 has returned 3 to the f of 6, what next will happen?
F of 2.
What will happen now? F of 6 is what? Fibonacci of 6 is equal to f of 5 plus f of 4, right? Fibonacci of 5 and Fibonacci of 4. Fibonacci of 5 has been calculated for f of 6. That is equal to what? That is equal to 3. Now what f of 6 requires next to be done? This Fibonacci of 6 requires what next to be done? F of 5 has been calculated, right? Now f of 6 requires the value of f of 4, right, for calculating itself. Am I correct?
Yes, sir. Yes, sir. F
So
of
what
4
will,
plus F of 5.
so f of 4 is already present inside the table. See, f of 4 is already present inside the table. So what shall I do? No need to call. If I want to calculate f of 4, I have to call f of 3 and f of 2. Am I correct? Now f of 3 again requires calculation of f of 2 and f of 1. Okay, so these extra function calls, I can do what? I can reduce. By what? I can just see the table. Okay, f of 4's value has already been calculated here. What value was it returning? 2. I have stored it here. So what? Nothing, no need to call these functions again. See the table. Okay, 2 is present inside the table. Return it directly to f of 6. No need to call these functions. Just see the table, return it to the previous function call. Okay, both the values I have got 3 plus 2. Finally, f of 6 value will be what? 3 plus 2. That is equal to 5. Is this point clear to all of you, or you are having any doubt? Tell me that.
Yes, sir. All clear.
Okay, let's take another example. So let's say I want to calculate seventh Fibonacci. For calculating seventh Fibonacci, what I require? Fibonacci of 6, f of 6 first. For calculating f of 6, what I require?
F of 5.
Okay, for calculating f of 5, what I require?
F of 4.
For calculating f of 4, what I require?
3.
F of 3.
For calculating f of 3, what I require?
F of 2 and 1.
Okay, f of 2 is fixed, right? What is it?
Yes.
What is it?
1.
1. Okay, so directly return it. Okay, so f of 2, see, f of 2 is fixed, we know that, and it is returning value 1, 2, that. Okay, f of 2 is equal to 1, this value will be returned to previous function call. Let's store it inside the table. Stored, right? Store it inside the table. Fine. Okay, so f of 2 has returned value 1 to f of 3, and now it requires f of 1 for calculating itself. It is also known that f of 1 is 0. F of 1 is 0, so let's return 0 from here. Now, what is the value of f of 3? Tell me. What is the value of f of 3?
1.
F of 3 will be equal to, now f of 3 will be equal to f of 2 plus f of 1. 1 plus 0, that is equal to 1, right? Now f of 3 has calculated itself that f of 3 is equal to 1 plus 0. So it will return this value 1 plus 0 to f of 4, right? So let's store it. F of 3 has calculated itself to be f of 2 plus f of 1. Let's store it here. Fine, right? Now what will happen? F of 2 has got a value from f of 3. F of 2, 4, sorry, this is f of 4, right? F of 4 has got value from f of 3. What it requires else to calculate itself? F of 4 equal to what? F of 4 is equal to what? F of 3 plus f of 2. So which part is required? F of 3 has been calculated. Which part is required?
F of 2, that is 1.
F of 2, right? And this is fixed 1, right? So this will be directly returned to the previous function call. Now, okay. It has f of 2 has returned 1. F of 3 has returned 1. So what will be the value of f of 4?
2.
How it is 2? F of 3 equal to 1, f of 2 equal to 1. Adding both equals f of 4. So let's store value 2, 1 plus 1 inside the table and return this value to the previous function call, right? Fine. Now tell me f of 5. What is f of 5 equal to?
F of 4 plus f of 3.
F of 4 plus f of 3. Okay, fine. Now f of 4 has returned 2 to the previous to f of 5. What it requires else to be calculated?
F of 3.
F of 3 needs to be calculated. But for calculating f of 3, do I require to calculate f of 2 and f of 1 again?
No, sir.
Now, means if I am going recursively, just assume.
Yes, sir.
For
Yes,
the
sir.
recursive method, do I require these two functions again to be calculated?
Yes, sir.
But yeah, since this value has been calculated and I have stored it here, I can directly return it, right? No need to call this function again. I have already calculated it and this is stored inside my table. Let's return it as it is. Let's return it as it is. So what will be returned?
1.
1 will be returned, right? So what is the value of f of 5 that I am getting now?
3.
Okay, 3. Fine, 3. Now, at first, let's do one thing. Let's store 3 here. F of 5 equal to 3 and then return it to the previous function call. Done? Fine. Now tell me one thing. F of 6 equals to what? F of 6 equals to what?
F of 5 plus f of 2.
F of 6 is equal to what? F of 5 plus f of 4. F of 5 has returned what?
3.
What is the value of f of 5?
3.
3. What now? I require f of 4, right? For calculating f of 6. Is it? Is it true?
Yes, sir.
So for calculating f of 4, if I am doing recursively, what I require to calculate f of 4?
F of 3 plus f of 2.
F of 3, f of 2. Both functions are required to be calculated for calculating f of 4, right? Now for again f of 3, I require f of 1 and f of 2. Am I correct?
Yes, sir.
So all these things I can reduce. I can avoid calling these 4 extra functions. How? See in the table. See in the table. Is there any value for f of 4? This value
Yes,
is
sir.
already there, right? I've already calculated. So do what? No need to call these functions. Return the value as it is to the previous function call. Whatever has been calculated earlier, return that only. No need to calculate it again. Okay, 2 has been returned, right? Now what will happen? F of 6 is equal to what? 3 plus 2, that is equal to 5. Let's store it that, okay, 6th Fibonacci I have calculated to be 5. let's store it inside the table, stored, and return it that since this f of 6 value is necessary for f of 7, return it to the previous function call, return 5. Okay, so what is f of 7 equal to? What is f of 7 equal to?
F of 6 plus F of 5.
F of 7 is equal to f of 6 plus f of 5. Now f of 6 has returned a value 5. Now for what else I require for f of 7? What else I require for f of? Okay, so if recursive method was there, f of 5 will be requiring what?
F of 4 plus F of 3.
F of 4 plus f of 3. If this is the recursive method, f of 5 will be requiring f of 4 and f of 3. Now f of 4 will again require f of 3 and f of
2.
2. F will again require what?
F of 2 plus
F of 2 and f of 1. Am I correct? And for calculating this f of 3 also, we require what? F of 2 and f of 1. Am I correct?
Yes, sir.
Okay, so all these extra function calls, how can I avoid them? Have I already calculated f of 5 somewhere?
Yes,
Stored
sir.
it somewhere? Just return that value. Just return that value to the previous function. So these all are avoided. No need to call that much of functions anymore. I have stored it somewhere. Return that as it is. So now f of 7 has got value what? Sorry. F of 6, sorry. F of 5 was 3, right? So this was the value 3. 3 will be returned here. By mistake, I returned the value of f of 6. Okay, 3 will be returned. So what will be the value of f of 7? 5 plus 3, 8. Now have you got a little bit clarity? What is happening when I am storing the results at some place? At any array, if I am storing the values, what is happening? I can avoid how many function calls? Have you seen it? Able to see that? These amounts of function calls I'm able to avoid. I'm able to say that, okay, I don't require these amount of function calls. If I am storing this, I can directly see into the table and can directly return the value. That's all. Tell me, is it clear or you are having any doubt?
All clear.
Any doubt you are having regarding this? Tell me that first.
Clear, sir.
Is it for all of you? Shall I take that?
Yes, sir.
So could you take another example? Except this Fibonacci series.
We will take. Just let me come to some points, then I will go to another example. How DP works. Okay. So see one thing. Okay, one thing I would like to discuss it. Okay, yeah. Just give me 2 minutes. I think it has hanged up. Okay, is the screen visible?
Yes, sir.
Yes, sir.
Okay, fine. So yeah, one thing I would like to ask. If I am calculating f of 5, let's say, first I require f of 4, then I require f of 3, then I require f of 2. Something like that is happening, is it? Something like that, this is happening. So, okay, which function among all will be calculated first? Which function among all will be calculated first?
So last,
F of 2 will be calculated first, right? Then f of 3 will be calculated. Then f of 4 will be calculated. Then f of 5 will be calculated. Is it true? Is it true that without f of 2, without calculation of f of 2, I cannot calculate f of 3? I have a boundation, right? So function calls, in whatever manner the function calls have been made, in the opposite order, the functions will be executed. Is this point clear to all of you? First, tell me that. In recursion, this is what happens.
it's so clear.
Okay, now tell me anything you can relate with stacks.
Yes, sir.
Anything you can relate with stacks. Whatever function is called at last executes first. Called last execute first. Any relation with stacks? Any relation with stacks? Any relation with stacks? Are you
Yeah.
able to figure out? In stacks, what happens? In stack, what happens? Whatever element comes at the last goes out first. Similarly, in recursion, whatever function write it somewhere. Similarly, we have something in recursion also. Whatever function is called last executes first. Right? So this f of 2, you can assume that this resides at the top. Okay. And this executes first and it is popped out. Then it goes back to f of 3. F of 3 then gets executed and it is popped out. Then it comes to f of 4. Whatever is the top, whatever is at the top of my stack, whatever is the top of my stack, that gets executed first. And then that entire function is popped out. That means once it is popped out, you can assume that it has completed its execution. Okay, so let's have a dry run, how the functions are called, and yeah, how this stack helps me to keep a track of where to go back. Okay. At first, what is called? Let's take another example here. Yeah. Fifth Fibonacci is called, right? Fifth Fibonacci is called. Fifth Fibonacci is called. Push it into the stack. Push it into the stack. Now for f of 5, what I require? For calculating fifth Fibonacci, what I require? Fourth Fibonacci. Push it into the stack. Push it into the stack. For fourth Fibonacci, what I require? Third Fibonacci, right? Push it into the stack. Now third Fibonacci, I require what? Second Fibonacci for that. Push it into the stack. Okay, so now this is fixed. This value is fixed to be 1. It will never change. Okay, so do what? It's already calculated to be 1. It returns a value to its previous function call. Okay, that is 1, and it gets popped out. Popping out means its execution has got completed. Now where it is returning a value somewhere, it is returning a value 1 somewhere, where it will return to the just immediate previous element inside the stack. Once it is getting popped out, what is the top of the stack that is remaining? That is f of 3. This particular value will be returned there. Getting it? Getting it? Right now, again, see, f of 2 has got popped out. F of 3 requires f of 1 also to be calculated, right? This has completed the execution. So now f of 1 will be getting inside the function, inside the stack, sorry. F of 1 is fixed, that is 0. Pop it out, and this 0 will be returned to this f of 3. Whatever element is left just towards its previous state, there the returned value is supposed to get returned. Getting it or not? Tell me that first. Or any doubt you're having?
Clear, sir.
Any doubt? What is happening? Any doubt? What is happening? Now see, f of 3 has got two values, 1 and 0. Add them. Now f of 3 is calculating itself. That is equal to 1 plus 0. Now, okay, it has completed, it has also calculated itself. What it will do? It will, the stack, it has, f of 3 has calculated itself. So its part is complete. Pop it out that, okay, this function call has been complete. Return this 1 to the current top of my stack. That is at f of 4. That's all. Now f of 4 requires what? F of 2. Now what is my current stack? After f of 3 has returned, what is the current state of my stack? What is the current state of my stack? F of 4 has got a value 1. Right? And now f of 4 calls that, okay, f of 3 has given me some value. I require f of 2, right? I require f of 2. The most recent function call is this. This will get at the top of the stack. F of 2 is fixed. Okay. For this, we have a fixed value, that is 1. Pop this out. Whatever is the current. After popping this, which one is the current top? Which one is the current top of the stack?
So f of 4.
F of 4. Return this to the current top. So, okay. This f of 4 has now got two values. Got two values, 1 and 1, right? One from f of 2 and one from f of 3. Fine. This part is done. Now f of 2, f of 4 will calculate itself to be 1 plus 1. Calculation part is done. Pop this function out. What is the, after f of 4 has been calculated, what is the top I have inside my stack?
F of 5.
Only one element, that is f of 5, right? Only one element, that is the f of 5. And this will get a value 2 for itself. Is this point clear to all of you? That, yeah, these function calls are maintained inside a stack. These function calls are maintained for calculating. Now, yeah, computer has to keep a track that, okay, which function call is made after what. So that is maintained using a stack. And this type of stack is called call stack. All these things are handled internally. You don't need to bother about it. These are all internal handling of computer.
How it is Fibonacci series? Are we doing Fibonacci series? Recursion with the recursion?
Yeah.
Oh, I'm still stuck over there.
No, I am not stuck. I am just keeping some points that what happens. I am taking up the call of call stack. What is a call stack?
Okay.
Okay. And see, for maintaining these function calls, computer requires some memory to be allotted. Okay. Computer has to allot some memory to keep this function calls inside a call stack. Okay. And this call stack memory too takes some part in space complexity. Now, at any moment, what can be the maximum number of function calls inside a stack? What do you think? What do you think?
Question repeat करना सर.
Particular किसी भी moment में maximum number of function calls call stack में कितना हो सकता है?
सर n ना जितना इनपुट देंगे
हाँ n
कैसे n हुआ वो बताओ?
इसमें
सर
इस केस में या मतलब किसी भी केस में
किसी भी फिबोनाची के केस में
सर
कितना
से
हो
100
सकता है?
देंगे तो 100 बार
n
होते
minus
रहेगा
1 n minus 1
Exactly. The maximum can be n minus 1. How is it n minus 1?
लास्ट वाला छोड़ के बाकी
देखो, why is it n minus 1? Because if I call for Fibonacci of n, it will call for Fibonacci of n minus 1, and it will keep on calling till it gets to Fibonacci of 2, right? Something like that happens. So how many function calls here? N minus 1 function calls.
ऑलवेज n minus 1 क्योंकि f1 और माइनस
ठीक है।
माइनस होता जाता है ना उसके बाद
ठीक है, n minus 1 function calls. So till I get to f of 2, all the function calls will be stored inside or not? Inside the stack. Tell me that.
yes it will store
Wait, you wait, Sahil. Let everyone participate also inside the class. What will happen? Okay, see, tell me one thing. If I am to calculate Fibonacci of 6 inside the stack, what it is going? What will go? Fibonacci of 6. Now next, what will happen? For calculating Fibonacci of 6, what I require?
f of 5.
F of 5. So Fibonacci of 5 will go inside the stack. Now calculating f of 5, what I require?
f of 4.
F of 4, right? Now for calculating f of 4, what I require?
f of 3.
F of 3. Okay, f of 3 is going inside. For calculating f of 3, what I require?
f of 2.
So okay, f of 2, right? After f of 2 is going inside, so how many function calls right now we have inside our stack?
5.
5 function call. Is it equal to n minus 1? Is it equal to n minus 1?
Yes, sir.
Okay, great. If n equal to 6, we have at least n minus 1 functions inside our stack called stack. Okay, for now, let's say f of 2 is fixed, right? Will return something. So pop it out and it returns 1 to our previous function call. Fine. So right now, after f of 2 has got popped out, how many functions are remaining inside the stack? F of 2 is fixed, right?
4.
Okay, fine. 4 is written. 4 is remaining. Now f of 3 requires f of 1. After f of 2 is has returned 1 to it, f of 3, it will go for f of 1. So f of 1 will get into the stack. F of 1 is fixed, 0 will return. So let's pop it out and it will return to the current pop. After it gets popped out, it will return 0 to the current top of my stack. Fine. So now f of 3, again, once I have, there are two conditions. F of 1, once f of 1 has got into the stack, how many functions were there? 5. Now after popping out f of 1, I have again 4 functions inside the stack. Fine. Now f of 3 is there. Let me just wipe out a little bit. Now see, f of 3 has got both the values. Am I correct? 1 and 0. F of 3 has got both the values 1 and 0. So it will calculate itself to be 1 plus 0, that is 1, and it will return to f of 4. So now f of 3 also gets popped out from the stack. It has calculated itself and it will return 1 to the current top of my stack. Getting it or not? Now what is the current number of functions inside my stack after f of 3 also had got popped out? What is the current number of functions inside my stack?
3
function calls, right? F of 4, let me write it here again. F of 6, F of 4 and F of 5 and F of 4. Fine, these 3 functions are there. Now after f of 4, f of 3 has been calculated, f of 4 requires f of 2 again to be calculated, right? Is it true? So okay, I require another function call, that is f of 2 to be calculated. Push it into the stack at the top. It is fixed, so it has just one line of execution. It will get popped out and it will return. F of 4 has already got a value from f of 3 to be 1. Now f of 2 will give it value 1 again, right? So now f of 4 has got two values for itself and it will calculate itself to be 1 plus 1. It will also get popped out and it will return to f of 5 what? Value 2. Fine. It has also returned 2. Now f of 5 requires what? F of 5 requires what? F of 4, it has already calculated for itself. So after f of 4 has got okay, after f of 4 has got popped out, we have only two functions left, f of 5 and f of 6. Now f of 5 requires another functions to be called, that is f of what? F of 3, right? F of 3 now needs to be calculated for calculating f of 5. Fine. So, okay, let's push f of 3 again. Let's push f of 3 again. Okay, for f of 3 requires how many functions? F of 2 to be calculated, it will return 1 to it. So it will get popped out. And again, f of 3 requires f of 1 to get calculated, it will return 0 to it, right? And it will also get, after f of, it will also get popped out. Fine, this part is done. This part is done. So now f of 3 has again calculated itself to be 1 plus 0. It will get popped out and return 1 to the previous function call, right? So now it returns 1 to f of 5. Now see, f of 5, how many values? F of 5 has got all the values for itself. It will do what? Calculate itself 1 plus 2, that is 3, and it will return to the previous function call. It will return 3 to the previous function call. So now at any point of execution, at any point, have you noticed that my call stack has got more than n function? At any point of our execution, that okay, at any time f of 3 is executing, any time that f of 5 is executing, or f of 6 is executing, have you got that this particular call stack has got more than n function? Has it arrived in your observation? What was the maximum number that we have noticed? N minus 1. This is the maximum number of function call that resided in my call stack. Okay.
So,
Yeah, tell me.
so this n minus 1 is particularly for Fibonacci series.
Yeah,
or for
particular for Fibonacci series.
Okay, sir.
Okay. So at any point of calculating our Fibonacci series, the call stack did not have more than n functions. So for keeping all these n functions, computer allots memory. For each function, computer allots some constant memory k. So what is the total number of memory to keep n functions into the call stack? What is the total number of memory that requires that is required to keep n function calls into the call stack?
NK.
Nk, right? For each function call, I require k. For one function call, I require k. So for n function calls, I require nk memory, nk amount of memory. Right? So what? This is an extra space. This is an extra space I require to solve my problem. Extra space. Okay. So what is the time inside the space? If I want to take only the recursive approach, if I am taking the recursive approach only, what is the space complexity I will be having? What is the space complexity I will be having? Big O of n. Why this is? Because this call stack takes maximum at any point of our recursive calls. We will have a call stack that will be storing the number of function calls, and maximum of n function at any point can reside in it for Fibonacci series. So it contributes big O of n space complexity to calculate my Fibonacci series. Okay. Little bit harder, right? Is it
Yes, sir.
totally
More
new
than
concept? Getting it now? How stacks can be utilized? How stacks are handled internally for your computers? And why this is a very important data structure? Is this point clear to all of you? Tell me that first. And even if you utilize the table also, utilize the array also, still call stack memory will be big O of n. Call stack memory in extra spaces of memory will be required at least at some point of time to calculate the Fibonacci series. Okay. Don't be silent like this, please. If you are having doubt, you can ask.
no, no, sir.
Okay. So yeah, if I tabulate the problem, if I use an array, if I use an array for calculating Fibonacci series, it reduces the time complexity to big O of n and space complexity remains big O of n. Okay. Using some extra space, using some extra array, okay. Using some extra array, I can reduce the time complexity from 2 to the power n to big O of n. This 2 to the power n is the worst time complexity one can have. Very bad. Okay. So yeah, let's go ahead with some other problem now. Okay, remember the staircase problem? Anyone? Any one of you remember the staircase problem? I am at the
Yes, sir.
ground. I am at the ground level and I want to reach the nth stair. I want to reach the nth stair.
Where to reach the next stair, na? We will.
I want to reach the nth stair, suppose. Now I can go up. I can take a jump and I can go up by one. Wherever I am standing, I can go up by one jump. I can go up by 2 jumps or I can go up by 3 jumps. Now tell me, what will be the approach for solving this problem? What you can do? Think of this 2 minutes, that what we have done earlier inside our class while we are doing recursion, and then give me the answer after 2 minutes. बोलो मिर्जा, या जुनैद.
सर उसको डीपी से करने का है.
हाँ ठीक है, पहले बताओ रिकर्शन से कैसे करते हैं, फिर डीपी लगाएंगे.
रिकर्शन में फंक्शन को कॉल करके f plus f माइनस
Think of it 2 minutes, then give me the answer. what we will do?
सर चैट मैसेज देखते हो क्या?
देखते हैं.
अच्छा.
Okay, what we can do? What we can do? Okay, how can I devise the recurrence formula? I am right now at 0. Where can I go? Where can I go? Where can I go? 2, 1, either from 1, 2 or 3. These three places I can go, right? Next, what I can do? From 1, where, at what places I can go? 2, 3 or 4. Now from 2, at what places, at what stairs I can go? From 2, if I'm standing at 2, at what places I can go? At 3, 4 or 5, right? From 2, I can go 1 stair up. I can go 2 stairs up, or I can go 3 stairs up. This part I can do, right? If I jump from 0, I jump to 3. From 0, if I jump to 3, where I can go? If from 0, if I jump to 3, then from 3, at what stairs we can go?
4, 5, 6.
4, 5 and 6, right? From 3, I can go 1 stair up. I can go 2 stairs up, or I can go 3 stairs up. So these are how the function callings we can do. Okay, one thing, suppose from any stair, I am standing at any stair X. So I make one jump and I go up and I go to a stair that is greater than n. So any answer I can get here? I jump either 1, 2 or 3. I make a jump either of 1, 2 or 3. I can either go 1 stair up, 2 stair up, 3 stair up. Okay, fine. So if I do these jumps, I go at a stair that is greater than n. So tell me, what shall I consider here? What shall I consider here? Any answer is possible at these locations?
तो क्वेश्चन समझ नहीं आया.
Staircase वाला problem. Staircase वाला problem.
सर आपने अभी जो बोले वो समझ.
Okay. So let's say I am standing at a staircase. एक random मान लो. I am standing at any random stair here. Let's say any in between stair I am standing here. This stair number is X. If I go 1 stair up, 2 stair up, or 3 stair up, I end up, after making the jump, I am going to a stair that is not the nth stair, but let's say n plus 1, n plus 2, or n plus 3, some stair greater than the value of n. So what shall I do then? I cannot come back, right? If I go to n plus 1, I cannot come back to n because no rule is there that I can come back also. If I go to n plus 2, again, I cannot come back to n. If I go to n plus 3, again, I cannot come back to n. So if I end up at any of these stairs, what shall I do? Any answers possible from these stairs? Any answer should I count for these stairs?
No, sir, no possibility.
Right? If this is the condition that, okay, right now my current stair is, wherever I am standing, my current stair is, whatever is my current stair number, if this is greater than n, I should return 0 from here. I should return 0 from here, right? Why? Because, okay, this was not supposed to be my destination. I cannot from this particular current stair number, I cannot reach, I cannot go back to my stair n. Why? Because if I am right now at a current stair CURR, let's say, and this is greater than n, as per the rule, I can go above it. I can go above it. From current, I can go to current plus 1, current plus 2, or current plus 3. I cannot come back to current minus 1. This is not the rule, right? So no point of going here. Why shall I even consider this option when I cannot come back? Okay, so whenever such condition arrives, I shall do what? Okay, no possible answers from this end. Let's return 0 from here. Let's return 0 from here. Okay, so how shall I devise my recurrence relation? What will be the recurrence relation here? F of 0 will be equal to what? Sorry, rather, let's say f of, let's say I am standing at current. I am standing at current stair, CURR. What should be the recurrence relation as per it? If I'm standing at a current stair, what should be the recurrence relation? I should make current plus 1, current plus 2, current plus 3. This is my recurrence relation, right? Addition of all of these things will give me the number of ways such that I can reach nth stair. I have to consider all ways. How many ways I can go from current to the nth stair? How many ways I can go from current plus 1 to the nth stair? How many ways I can go from current plus 2 to the nth stair? How many ways I can go from current plus 3 to the nth stair? All these 3, if I add, these will contribute my answer to how many ways actually I can go from the current to the nth stair. So tell me one thing, what will be the base case for it? What will be the base case for it?
If n is equal to 1 or n is equal to 0, then return 1.
Or we can say if my current stair is equal to n, return 1. That means I have reached my destination. I have at least one path. I have at least one path to reach the nth stair. Am I correct? If my current stair is becoming equal to n, that means at okay, I have found out at least one path to reach the nth stair. Right? So return 1 from here. So how will we code this using recursion? How will we code this using recursion? Let's keep the list because that will be handy, right? So let's say stair. Def num of number of ways. And let's say I want to reach the nth stair. Right now, let's say I want to reach the nth stair. Right now, I am at the current stair. So what I can say, if current equals n, that means okay, I have reached the nth stair, return 1. That okay, I have found at least one way to reach the nth stair. Else what shall I do? Else what shall I do? If my current is not the nth stair, what I can do? What I can do? I can just say return. How many ways are possible? How many ways are possible if I go to one stair up, if I go to one stair up and I want to reach the nth stair, to that add how many ways are possible? How many ways are possible if I go 2 steps up? If I go to 2 steps up and I want to reach the nth stair. And again, how many number of ways are possible? If I go 3 stairs up and I want to reach the nth stair, right? This is the entire things that I require. Okay, another thing, another consideration that we have made, right? If my current is greater than n, I have gone to a step that is greater than n. Any considerations made to be here? No. So directly return 0. That okay. From this, if I am at a current staircase, that is greater than n, no answer is possible from there. So just return 0 from here, right? So yeah. So let me try this. Okay, you want to let me right now. Initially, I am standing at my current is 0. That I am standing at the ground floor, and let's say I want to reach the 7th floor or the 7th staircase. What will be the answer?
सर प्रिंट में उसका फंक्शन का नाम लिखिए.
Okay, sorry. Thanks. Print number of ways. And let's. Okay, 44. Yeah, tell me.
सर जी फिबोनाची सीरीज का वो कर रहे हैं ना, प्लस कर रहे हैं ना?
नहीं, क्यों? ये तो फिबोनाची है ही नहीं, और फिबोनाची क्वेश्चन चला गया.
अच्छा चला गया, सॉरी डिस्कनेक्ट हो गया था मैं.
अच्छा, कोई नहीं. Okay, fine. So 44 number of ways. Have we done it correctly? Any small example with which we can verify? Okay, let's say I want to reach the 4th floor. What is the expected answer? 7. How is it 7? How is it 7? From the 0th floor I start. From 0 I can go to where? Either 1, 2, 3. From 1 where can I go? From 1 where can I go? 2, 3, 4. From 2 where can I go?
3, 4.
3, 4.
1.
5.
5 तो is not possible, right? If I go to 5, so
5
no answer
not
is possible.
possible.
सर 1 जा सकते हैं ना वापस?
1 पे क्यों जाएंगे
रिटर्न
भाई?
नहीं
मैं
जाना
तो
है.
nth स्टेप पे
रिटर्न
जा
जाना
रहा
ही
हूँ.
नहीं है.
रिटर्न जाना नहीं, ओके.
ठीक है. From 3 where can I go? From 3 where can I go? Can I go to 4 directly? One step from 3 I can take. I can go to 4. From here 4, already 4 is there. Now from 2, how many paths are possible? I can go to 3, I can go to 4, right? Now from 3 again I can go to 4. Now from 3 I can go take only one step, that is and that will take me to 4. So how many paths are possible? How many paths are possible? From 0 I have gone to 1, then I have gone to 2, then I have gone to 3. Okay, yeah, 3. So this will be 4, right? And from 3 I have gone to 4. Just by taking one steps, I have gone to 4 from 0. Now again see. From 0 I have gone to 1. From 1 I have gone to 3. Then 3 I have gone to 4. Now from 0 I have gone to 1. From 1 I have gone to 2. From 2 I have gone to 4. Right. Now next. Now next, what are the else paths that I have taken? From 0 I have gone to 1, then I have gone to 4 directly, right? Next, from 0 I have gone to 2, I have gone to 3, I have gone to 4 then. From 0 I have gone to 2. Now from 2 I have gone to 4, and from 0 I can go to 3, and I can go to 4 from here, right? Directly we can do these things. So how many paths are there? 0, 1, 2, 3, 4, 5, 6, 7. So exactly 7 paths we have printed. Okay.
तो सर इसको जो प्रोग्राम कराया है उसमें ड्राई रन करके दिखा दोगे एक बार?
बहुत देर लगेगा. जस्ट इंट्यूशन समझ
अच्छा
लो
चलो
यहाँ पे हो क्या रहा है.
अच्छा आप सिर्फ उसको कम कर दो ना, उसका रेंज कम करके टाइम कम लग जाएगा.
टाइम तो नहीं, ड्राई रन में बहुत 3 फंक्शन कॉलिंग होती है यहाँ पे, ठीक है, बहुत देर लगता है।
सर अगर आप सिंपली 3 का कर दोगे तो शायद।
ठीक है, देखते हैं, चलो 3 का, 3 का शायद कम हो जाए। और ये सब मैंने ड्राई रन ऑलरेडी करके दिखा दिया है रिकर्शन के क्लासेस में।
नहीं,
4 राइट।
नंबर ऑफ वेज इसका करके दिखा दिया था।
ये पूरा रिकर्शन में तो मैं प्रॉब्लम लिया था मैंने।
अच्छा चलो ठीक है, अगर पॉसिबल नहीं है
चलो
तो रहने
4
दो।
का 4 का करते हैं।
ठीक है।
Okay, I start at 0. I start at 0. Now tell me, current equal to n. I want to reach the third stair. Current equal to n. True or false?
False. False.
False. Is this condition false?
Yes.
Okay, now what will happen? Return number of ways. First, this will be current plus 1 to n. First, this function will be made. That okay now? Number of ways from 0. I transit to 1 and I want to reach n. Okay, it will call for 1. Okay, this is a new function called.
Yes.
It will start again from the beginning.
Though both will false.
Both are false. Now again it will call for what? Current plus 1 to n. It will call for current plus 1 and n. What that will be? What will be the current plus 1?
2.
2. Fine. Now no new function call. Again both are false, right? Again both are false.
Yes, both are false.
Now it will call for again number of ways from current plus 1. That is 3, right? 3. Fine. Now what will happen?
Now it will return 1.
It will
And-
return 1 to the previous, right? For this
Yes.
function call, this will return to the previous function call.
Yes.
This will return 1 to the previous function call. Okay, that okay. One path is there. From one path we have find out, that is 0, 1, 2, and 3. This path is done. Fine.
Done.
Okay,
ये
now
बाकी का समझ आ गया।
हम्म?
मुझे आ गया बाकी का समझ। If anyone has to ask, can ask.
shall I carry on the dry run? Or
मुझे
ठीक
तो
है,
वैसे
ठीक है।
समझ में आ गया है। If anyone else want further describe it, then can ask. मुझे
shall I
समझ में आ
carry on the dry run? So what do you think? Okay, yeah, let's carry on the dry run only. Okay, so now this part is complete. This part is complete. Now number of ways of 2 has completed this function call. Now it will go for this function call. Number of ways current plus 2. That is okay. Now it will call for number of ways current plus 2. Current is 2. Current plus 2 will be what? 4. Now again, is
Yes.
it coming up? Again for this function call, most recent. Is this condition true? True. Okay, so is this condition true?
True.
4 पे है, देखो 3 पे जाना
नहीं,
है।
greater 0 आएगा।
This condition is false first, but this condition is true, right? This condition is
Yes,
true.
yes.
So it will return 0 to the previous function call. That okay. From 4, I cannot reach to anywhere called 3. From 4, is it possible to reach 3? No. So it will
No,
return 0.
No. Yes.
Okay, now it will come back here and it will call. It has completed 2 function calls. Now it will call for this function call.
This function.
Okay, right? That okay. Now from 2, I will go to 5. Now again, see for this function call, this is false, but this is true. So it will 2
Yes.
return 0. It will 2 return 0 to the
Yes.
previous function call. Fine.
Yeah. Okay. So.
Fine. So now 1 plus 0 plus 0, it will return 1 to the previous function call, right? Okay,
Yes.
fine. Now number of ways of 1 has completed till here. Only one function. Now
Yes.
it will also go for 2 other function calls. What are
Yes.
they?
2, 3.
It will go
2.
for number of ways of
1 current.
1 current plus 2, that is 3.
Yes.
Okay, this function call will be called. Now see, for this is the most recent function call I have. This is for this condition is getting true. This condition is getting true.
Getting true. Yes.
So it will return 1. It will return 1 to the previous function call. And now we have got another path. What is this? From 0, I can go to 1 and then I can go to 3. Another path we have got. Okay, fine. Now this also has completed. Now till this function call, number of ways of 1 has got completed. Now it will calculate this number of ways current plus 3. It will call for number of ways. Current plus 3 is what? 1 plus 3. 4. So now 4 is greater than, for this particular function call, this condition is false, but this condition is true, because from 4 I cannot reach to previous staircase 3. This is not possible. So it will return 0 to the previous function call. Now number of ways of 1 has completed its calculation, that is equal to 1 plus 1 plus 0, and it will return 2 to the previous function call. This part is done. This part is done. Okay, let's move on to some. Now from 0, what functions we have taken till now? These amount of functions are called. Now 0 has, number of ways from 0 has seen only one function call, that is this. Now it will go for the second function call, that is number of ways of current plus 2. It will call for 2. It will call for 2. And then from number of ways of 2, what will happen? Number of ways of 2, see, again, number of ways of 2 requires what? Again, from number of ways of 2, do I have to call again these 3 functions? Is it true? These three functions that I have already calculated, will they be required here also? Will they be required here also? See, from 0, I went to 1. From 1, I went to 2. From 2, I went to 3. From 3, I went to 4. Then 3 had 2 more function calls. 4 and 5, right? Now 2, after 3, 2 had 2 more function calls. That is 4 and 5, right? Fine. Sorry, this is 5 and 6. This is 5 and 6. Now again, 1 has 2 function calls after this, that is 3 and 4. Okay, so see, once this 1 has got completed for 0, 0 will 2 again call for 2. 0 will 2 again call for 2. And for 2 again, 2 will go for 3, 3 will go for 4, 5 and 6. Right? And again, after that, 2 will go for 4 and 2 will go for 5. Fine. So this, once I'm calling for this 2, these amount of function calls using my recursion are getting repeated. Using recursion, these amount of function calls will get definitely repeated. So what can I do for this? What can I do for this?
Just store the value.
How can I store? Okay, how many? What is the length of my array that I require for storing this? What is the length of?
Three, I think.
That is n, right? Maximum number of stairs. Maximum number of stairs I require.
Yes, yes.
Is n. So, okay, for each stair, I have results for each stair. I have results for each stair that, okay, how many ways are required to reach 1? How many ways are required to reach 2? How many ways are required to reach 3? How many ways are required to, how many ways are required to reach 4? All the results I have. All the results I require, so that finally I can get a value that, okay, how many ways are required to reach n. All these values from 1 to n-1 I have to calculate. So what is the length of my array that I require? N, right?
Yes.
N sized array I require. So let's do that. Okay, fine. Let me at first show you one thing. What will happen if I try to calculate for the 15th stair? Let me, I want to calculate for 15th only. Okay, the 15th part is coming, right? Let me increase that somehow. Okay, so 21 is also, 20th one is also working fine. What about our 35? What will happen? So, अच्छा,
ज़्यादा memory ले रहा है.
So once we have called for Fibonacci of 35, how many time it had required for getting calculated? 2-3 seconds, I guess, right? Within 2-3 seconds, I guess our Fibonacci of 35 has got calculated. Was it the case? But yeah, see, these 2-3 seconds means the Fibonacci part that we have seen, such kind of requirement has arrived that, okay, we have to wait and on and on and on for the 100th Fibonacci. But for this case, we have achieved the same thing for 35th Fibonacci only. Why is it so? What do you think? For 35th Fibonacci only, I have to wait for 35th number of n. Here at this problem, I have to wait the time that was equal to the 100th Fibonacci. Why is it the case? What do you think? Number of calls is here more, right? Number of calls here, see, for each function call f of x, I had 3 more function calls associated with it. Am I correct? So we can expect that number of redundant function calls, number of redundant function calls that I will have in this problem will be way more, as compared to Fibonacci. Right? So now to stop these function calls, what we can do? To stop these function calls, what we can do? To stop these functions calls, what we can do? What we can do? We can store this entire result somewhere. Okay. Let's define another list for this. That is number of ways list equal to, let's I can do one thing. I will store it before returning. I can store it, that how many I can store the value, and then I will return. And before even going to the calculation, what I will do, I will check the list. I will check the list that, okay, if the answer has already been calculated, return the answer as it is. Return the answer as it is. No need to recalculate the things, just return as it is. Okay. So yeah, let's try that now. Let's try that and let's see. Okay, then let me assign it to be 100 so that we can check that, okay, our 35th has been calculated or not. What was it, man? Okay, invalid syntax. I think Python doesn't support the assignment. Let's do one thing. And return the result that we have calculated. Return. Have we calculated the result in some sort of time within just 1 second? Right? Even if you now calculate for the 1000th one, that is okay. Let's go for calculating the 999th. If I want to calculate for the 999th stair, and if you want to calculate, see, okay, yeah, maximum recursion depth. So okay, you cannot do this because yeah, this is taking away our everything. But yeah, I will show you how can we even calculate that. Okay, some kind of problem we are getting that, okay, 999. If I want to calculate, let's say the 999th for the problem, if I want to reach the 999th stair, what I will do? Means if I want to approach using this approach, I am getting that, okay, maximum recursion depth has been exceeded. That, okay, all the memory has been exhausted by my computer. Fine.
आधा आधा करके
नहीं, आधा भी करने की जरूरत नहीं है, बताते हैं. So what happens is that the approach that we have used here, we have done what? We are repeatedly calling the recursive values. Am I correct? We are using recursion only. We are using recursion. We are using recursion, and whenever we are getting a result, we are getting a result of f of n. We are storing that inside a table. We are storing that inside a table. So yeah, such kind of approach is called top-down approach. Top-down approach. But still there is a recursion here. We can avoid even this recursion using some other kind of DP. And that kind of DP is called bottom-up approach. Bottom-up approach. Firstly, tell me how many of you are comfortable with this right now. I know this will be hard, but how many of you got to know that, okay, we are storing this inside a list, and whenever I will be having the result calculated, I will check for it and I will return the result as it is.
एक्चुअली आपने उसका नंबर ऑफ वेज को 1000 से मल्टीप्लाई किया है ना, तो देन इट्स आई थिंक टेकिंग अ टाइम. अगर आप उसको मल्टीप्लाई बाय 10,000 कर देते तो आई थिंक 999 वाला
नहीं यहाँ पे दिखा रहा है, देखो, मैक्सिमम रिकर्शन डेप्थ एक्सीडेड,
क्योंकि आपने लिस्ट का मल्टीप्लाई बाय 1000 किया है ना.
हाँ, लिस्ट से तो कोई ताल्लुक नहीं है ना.
स्टोर तो सर लिस्ट में कर रहे हैं.
स्टोर तो 99, तो अगर मैं यहाँ पे 1000 की लिस्ट बनाता हूँ तो 999 तो लास्ट इंडेक्स होना चाहिए.
अच्छा, मेरे को लगा शायद अगर उसको आप 10,000 कर दोगे
तब तो सेगमेंटेशन फॉल्ट एरर आएगा. सेगमेंटेशन फॉल्ट कि आपने कहीं कुछ बैड मेमोरी एक्सेस कर ली है जो आपको अलॉट नहीं हुई. ठीक है,
ओके
ओके. फर्स्टली टेल मी वन थिंग, how many of you are comfortable how we have calculated the number of ways using calling recursion? We have recursively called our function, and whenever we are getting some result, we are storing that into the table. And before going for any function call, before going any further function call from f of n, okay, before going from any further function call from f of n, I am looking into the table. I am looking into the array. If this is already calculated, I won't make these function calls. I won't make these function calls. Rather, I will, whatever value has been kept here, I will return that to my previous function call. Is this approach clear to all of you or not? Tell me that.
नहीं,
मतलब क्या प्रॉब्लम है?
न्यू वाली नहीं समझ में आई.
न्यू वाली एज इन
जो आप बॉटम अप अप्रोच बता रहे हो.
बॉटम अप तो बताया ही नहीं है, बताएंगे अभी.
अच्छा, पुरानी वाली तो क्लियर है सर.
हाँ, so using this, we are getting, when we use this top down approach, we have some extra space complexity called call stack space complexity. Whenever we make recursive calls and we store it into the table, into the array, we have some call stack memory also associated. Some amount of recursive calls are there, and we require this call stack to store the order. Okay, and once I am trying to calculate how will I reach from 0 to the 999th floor, how many ways are there? We are getting that, okay, so the amount of recursive calls has exceeded. I cannot do this if I am just using, if I am just making the recursive calls, and I'm doing what? If I'm just making the recursive calls and I am just, whenever the result is arriving, I'm storing that into the table. This way will not work if I want to go from 0 to the 999th floor. I have to think of something else. Now the problem has arrived. Right? So what we can do in this case? What we can do in this case? Now let's do one thing. Let's do one thing. Let me comment it out. No requirement of recursive functions anymore. Why to go for it if it is not even to solve? How can I go from 0 to 999th floor? Tell me one thing. Tell me one thing. Let me take an array of length 6, let's say, and it starts from 1 only. Assume that the indexing is from 1. Okay, okay, no, don't assume so. Let's assume that I am at 0. I'm at 0 only. So, okay. Tell me one thing. In how many ways I am right now standing at 0? I am right now standing at 0. So how many ways are required for me to reach 0? I am right now standing at 0 only. Am I correct? From 0 only, I have to go to the nth floor. So in how many ways I can reach this index 0? That is, in how many ways I can go to the ground floor? How many ways are possible? Any idea? I am already there. I am already there. I am already standing at the ground floor. So I require one answer. In how many ways I can reach this? In how many ways I can reach 0 or the ground floor? Will it be 0 or will it be 1? Which one? Which will it be 0 or will it be 1? Someone has given me the answer 1. Somebody has given me the answer 0. It should be 1, right? It should be 1. Why? I don't require from 0. If I'm already standing at the 0th index, without taking any step also, I have reached there. Before doing anything, I am already there. So there is at least one way, right? Such that I have reached this floor. There is at least one way, right? That, okay, you are already standing there without taking any step, any further step also, you can reach this ground step. So there is at least one way. So yeah, let's say that, okay, there is only one way to reach this floor, that is the 0th floor. Now tell me, if I want to calculate for 1, how many ways, in how many ways I can reach 1 from its previous stairs? In how many ways?
Sir, 2 way.
How come 2 ways?
बिकॉज सर 0 से 1 के लिए एक हो जाएगा, फिर 1 में अगर खुद स्टैंड करता है तो
नहीं, 1 तो खुद से स्टैंड कर नहीं सकता ना. एज पर द क्वेश्चन I can only start my journey from 0 only. As per the question, I
0
cannot.
to 1 तो एक ही है रास्ता.
एक ही है ना. I can start my journey from 0 only. So there is only one way to reach 1. That is, from 0, take one step and reach 1. There is only one way. Now come to 2. How many ways you can reach 2? How many ways you can reach 2? In how many ways you can reach 2? How many ways we can reach 2?
One way.
One step I can take from 1, right? One step. From 0, I have already one
2.
path.
Yes,
Okay,
yes.
right? 0 to 1 I have already reached, and there is only one way of doing that. So what I can do is that from 1 I can go, I can take one step and I can go to 2. So there is there. Now from 0, what I can do? I can directly jump 2 stairs up and I can reach 2. Is it correct?
Yes, two way.
So how many ways?
Two ways.
So there are 2 ways, right? How many? From 0 I can directly reach 2. From 0 I can go to 1, and from 1 I can go to 2. So there are 2 ways here. There are 2 ways here. Okay, now come to 3. Come to 3. How many ways? Come to 3. How many ways? How many ways?
4, 7. अभी तो
हाँ।
निकाला था पीछे.
4 निकाला था. 4 7 था 4 के.
4 sorry.
How many ways are how many ways and how many ways I can reach? See, already from 0 I can go to directly 3 one way. Now from 2 I can go, I can take one step and I can go to 3. I can go to 3. Anything else I can do? From this 2 also I can take a step and can go to 3. And from this 1 I can again take 2 steps and I can reach this 3. So how many ways? 4 ways. Is it correct? Okay, so let me redraw my array. Let me redraw my array and let me see. Zero I can reach once. 0, 1, 2, 3, right? So this one I want to calculate. How many ways we have done? From 2, from stair 2, I can come to 3, right? Is it correct? From stair 2, I can come to 3 by just taking one step. Now in how many ways I have reached stair 2? How many ways? 2 ways, right? In 2 ways I can reach stair 2. One is from 0, 1, 2 and another is directly from 0. So using these 2 ways, from if I take 2 different parts, so if I take 2 different parts, I will have 2 different ways of reaching 3. So okay, from 2 I can reach 3 in 2 ways. Okay, in how many ways I can reach 1? Only one way. I can reach 1 in only one way, that is taking one step from 0. So okay, from 1 I can go to 3 by taking 2 steps. Okay, from 1 I can go to 3 by taking 2 steps. So how many ways I can reach 3 from 1? Only one way. So okay, see, from 0 I can directly come to 3 by taking 3 jumps, straight 3 jumps. So from 0 I can again reach 3 by taking 3 jumps. So how many ways are there? 4. Okay, fine. Let's come to next 4. Now tell me in how many ways we can reach 4. In how many ways we can reach 4?
जितने पिछले के थे उसमें 2 जोड़ दो और.
See, this 3, ये जो 3 है, this 3, I can take one step from this 3 can reach 4. I can take one step from this 3 and I can reach 4. I can take one step from this 3 and I can reach 4.
Yes.
I can take one step from this 3 and I can
4
reach
और
4.
जोड़ देंगे.
Okay. Now tell me, from 2 also I can reach 4 now by taking 2 steps. Taken. Okay.
Yes.
Okay. From this 2 also I can reach 4 by 2 steps. Taken. From this 1, can I reach 4 from 1? Taking 3 steps from 1. Will it be possible?
Yes.
So I can reach 4 from this 1 also by taking 3 steps. So how many ways are there? 1, 2, 3, 4, 5, 6, 7. Getting it?
Yes.
Is it? So from 3 I can, from 3 observe, from 3 how many paths are there? From 3. From 3.
4 was there.
4 are there. So the number of ways in which I can reach 4 that amount will be added to 4 also. Is it? Sorry, number of ways in which I have reached 3. Will that contribute to how many ways I will reach 4? Is it contributing? 4 in 4 ways I can reach 3. So in exactly using those threes, I can constitute 4 paths for reaching 4. Okay, so 4 added here. Again, what is happening? I can reach 2 in 2 ways. So exactly from 2, I can reach 4 in 2 ways. Is it? See the path. I can reach 2 in 2 ways exactly. From 2 extra paths, each 4 will be there from those 2. Okay, added 2. Now from 1, I can reach 4 by adding 3 steps, by taking 3 steps. But in how many ways I can reach 1? Only 1. So that will also get added. Fine. Fine. So can you observe one thing? If I am to calculate the result for how many ways I can reach n, I have to calculate in how many ways I have reached n minus 1, in how many ways I have reached n minus 2, in how many ways I have reached n minus 3. If I add all of these things, I will get what is the result for f of n. Just similar to Fibonacci. Is it?
Got it.
Is it?
Got it. Yeah.
Is it what the observation we have seen it here?
Yes.
We are just storing that. Okay.
हेलो अरे
Yeah, tell me.
आशीष का लग गया
पहले वाले में हम प्लस करके उसको पास कर रहे थे वैल्यू को, और फिर बाद में उसको भी मतलब सबको प्लस कर रहे थे लास्ट में। तो इसमें माइनस कर रहे हैं, तो कर तो प्लस ही रहे हैं, लेकिन फंक्शन में माइनस वैल्यू पास कर रहे हैं।
हेलो
हेलो, फोन पे बात कर रहे हो या फिर यहाँ पे कुछ पूछ रहे हो?
सर
बोलो।
अभी और एक फॉर्मूला भी निकला है ना, जो
तुम्हारी आवाज ही नहीं आ रही है कानू।
अभी आ रहा है सर?
हाँ आ रहा है।
हाँ, बोल रहा हूँ कि 0th इंडेक्स में 1 वे, तो हमारा नेक्स्ट में 1 आ रहा है।
हाँ ठीक है, कोई प्रॉब्लम नहीं है।
उतना हम ऐड करते जाएंगे जब
रुको, तुम्हारा आवाज सही से नहीं आ रहा है, फिर कम हो गया।
सर जैसे कि अभी 3rd इंडेक्स में 4 वे आया,
हाँ
तो उसको हम ऐड कर,
क्या
उसको
करेंगे?
ऐड करने के बाद नेक्स्ट 3rd इंडेक्स में जितना वेज आया उसको अब, तो आ रहा है ना रिजल्ट सर?
समझा नहीं। थर्ड इंडेक्स में जो आ रहा है,
3rd इंडेक्स में 4 वेज आ रहा है।
हाँ, इट इज इक्वल टू f of 0 प्लस f of 1 प्लस f of 2 आ रहा है। प्रीवियस 3 को मैं ऐड कर दे रहा हूँ तो मेरा आंसर आ जा रहा है।
नहीं, मेरा बोलने का मतलब ये नहीं था सर। इंडेक्स को और वो इंडेक्स वेज है।
तुम्हारा आवाज ब्रेक कर रहा है हेवीली, मुझे कुछ समझ भी नहीं आ रहा है।
भाई आप टेक्स्ट कर दो ना।
हाँ मैं टेक्स्ट कर लेता हूँ।
ठीक है, so let's code it using this method. So let's code it. Okay, so no need to now do anything. Created the list already, right? I've created the list already. Okay, I guess यहाँ पे हम लोग ने एक चीज नहीं किया था, हमने ग्लोबल कुछ नहीं लिया था, राइट? ये एक प्रॉब्लम कर सकता है। ओके या नंबर ऑफ वेज, ठीक है कर लिया। तो चलो एक काम करते हैं, नंबर ऑफ 0th इंडेक्स तक तो एक ही तरीके से जा सकते हैं, 0th इंडेक्स तक तो एक ही तरीके से जा सकते हैं, दैट इज एक तरीका। दैट ओके, ये तो होगा ही, ठीक है। एल्स चलो स्टार्ट करते हैं। फॉर आई इन रेंज 1 से स्टार्ट करो, and let's take an input for n, that which nth stair I want to go. Okay, let's finish up at n plus 1 because nth for nth I have to calculate. Fine. So what will I do here? I will check if previous three function calls, previous three states should be considered, right? How can I reach f of n minus 1? How can I reach f of n minus 2? How can I reach f of n minus 3? These three states will add up together and they will constitute to the answer of f of n. This is what we are seeing in this example. So what we will do? First check if I minus 1, is it greater than equal to 0? Is it greater than, because from 0 is the last state from which I can jump to somewhere. There is no concept of negative states, right? Above which I can go. So if my previous state, if I go back to just one stair, is it greater than equal to 0? If it is, then only I can do what? I can take, okay, number of list of I plus equal to, it will add all the ways of number of list of I minus 1. Similarly, I will check for I minus 2. Is this greater than equal to 0? If it is, do what? Number of, add all the ways through which I have reached. It will add up all the ways through which I have reached I minus 2 to where? For the answer of number of ways I want to reach I. And last, I will see this. If I minus 3 is greater than equal to 0, then number of ways of I will be equal to, will add in itself all the ways through which I have reached, I minus 3. Okay. Now at the end, print, number of ways of list of n, the nth stair. In how many ways I have reached the nth stair. Let's do that. And yeah, pi test.py. For what value of n you want to calculate? Tell me. Let's take the value of 4. Getting the correct answer 7. For value of 4. Let me calculate for 10. 274 ways. Let me calculate for 999. See, such a long answer. Ever seen such a big number? For 999. How many ways are there such that from 0 I can reach 999? So this is the answer. What is the time complexity for this? Not more than big O of n. I am just going from 1. I am just calculating all the results from 1 to nth stair. From 1 to nth stair. So the result, so the time complexity for this is big O of n. What is the space complexity? We are using this list extra. So that too will give me big O of n space complexity. We are not relying on recursion. Okay. So recursion, if I do go on for, okay, I will start with recursion and then we'll go on calling and calling function. It will give on, it will start returning something. And once it is returning, I will store the results in my given array, in my this list. Such kind of structure when I have, I call this a top-down approach. Okay. And once I directly formulate the things that, okay, what is my recurrence relation? Don't rely on recursion. And I directly calculate using loops or iterative manner. I call this a bottom-up approach.
तो इसमें रिकर्शन हुआ नहीं ना फिर?
नहीं, इसमें कोई रिकर्शन नहीं हुआ. इजी हुआ ना मेथड? कोई रिकर्शन नहीं, कुछ नहीं, जस्ट डायरेक्टली फॉर्मुलेट करो और बैठा दो. टेबल भर दो, बस टेबल भर दो. यही करना है हमें. टेबल भरना पड़ेगा. भर दिया. हमें मालूम लग गया कि ओके nth स्टेयर पहुंचने के लिए मुझे जानना है n-1 स्टेयर कितने वेज में जा रहे हो, n-2 स्टेयर कितने में जा रहे हो, और n-3 स्टेयर. इन 3 जगहों को मैं कितने वेज में आ सकता हूँ. सारे वेज को ऐड कर दो तो मुझे n स्टेयर का रिजल्ट मिल जाएगा.
मेरे को एक चीज नहीं समझ में आई. इफ i-1, i-2, i-3
see if I am at a stair, right? Suppose that I am standing at stair 2. If I am standing at stair 2, so from 1 I can go to 2, from 0 I can go to 2. Can I reach any step I can make from 3? Sorry, सो ये दो ही पॉसिबल है ना, 0 1 और 2 दो ही पॉसिबल है, ठीक है। बट अगर मैं 4 पे जाऊं, 4 का कंसिडर करूं, आई कैन रीच 4 फ्रॉम 3, फ्रॉम 3 आई कैन रीच 4, फ्रॉम 2 आई कैन रीच 4, फॉर 1 आई कैन रीच 4. Okay, but this is not the case for 1 and 2. There is no concept of taking 3 steps for somewhere, from somewhere, so that I can reach 2. किसी नेगेटिव एलिमेंट से तो आ नहीं सकते ना 2 पे 3 स्टेप्स लेके। तो वही देख रहा हूं कि मेरे पीछे क्या क्या पॉसिबल है। अगर मेरा करंट में स्टेप कहीं पे खड़ा हूं तो 1 स्टेप लेके मैं कहां से आ सकता
तो
हूँ,
आई
2
माइनस
स्टेप्स लेके।
आई माइनस 3 मतलब आई माइनस 4 क्यों नहीं लिया हमने फिर?
3 ही स्टेप ले सकते हैं ना, क्वेश्चन में तो 3 ही है। एक स्टेप लेके आ
तो
सकता हूँ यहाँ पे, 2
वो
स्टेप्स लेके आ सकता हूँ, 3
वो
स्टेप्स लेके आ सकता हूँ।
सर वो तो मैक्सिमम 3 स्टेप्स के लिए है ना, 3 स्टेप।
हाँ
तो अगर यही केस अपने 10 के लिए ले लेते हैं या 6 के लिए ले लेते हैं,
हाँ, तो फिर
तो
सबको चेक करना पड़ेगा।
आई माइनस 3, आई माइनस 2 और आई माइनस 1 का नहीं मेरे को समझ में आ रहा।
देखो इधर देखो, दिखाता हूँ। आज बाउंसर लगा या यॉर्कर लगा, कौन सा लगा बताओ।
नहीं ये
सब
लास्ट वाला बाउंसर हो गया है थोड़ा, पहले वाले तो सिक्सर ही गए हैं।
अच्छा
समझ
देखो,
में आ गए हैं पहले
देखो
वाले।
मेरा अलाउड क्या क्या है, मेरा अलाउड क्या क्या है, हाउ मेनी स्टेप्स आर अलाउड। आई कैन कम टू 2, आई
Don't take
कैन
the
रीच।
example of 2 sir, don't let's take the example for 4 or 5.
Okay, let's take the example from for 4. Okay, I can take how many, okay, how I can take how many steps to reach 4, tell me that. From 3 I can reach to 4 by taking one
By
step,
one step,
correct?
yes.
For this that condition, okay, that is it possible, is there any step that is existing before me such that from there I will take just one step and reach 4, one condition.
Okay.
Is there any step that is existing before 4 such that from there I will take 2 steps and I will reach here?
Yes, 2.
Similarly, I will check for another one. Is there any step that exists before 4 such that from there I will take 3 steps and I will reach 4?
Okay.
Is this things, is the same thing possible for 2? Tell me that. Only 1 and 0 are
No,
there.
it's not possible for 2.
From I can take 0, from 0 I can take 2 steps to reach 2, from 1 I can take 1 step to reach 2, right? But
Yes.
I cannot take 3 steps from anywhere to reach 2, right? It is not possible. So that's why for keeping these cases I have to continuously check.
But if the case is for a 5, तो
Yeah.
5 से पहले 1 है तो वहां पे 4 स्टेप बन जाते हैं।
पर यार मैं तो 1 से 5, देखो 1 से मैं 5 पे जा ही नहीं सकता, कोई 1 2 और 3 स्टेप्स लेके जा सकता हूं? जा ही तो नहीं सकता मैं। 1 से मुझे आइदर पहले 2 पे जाना होगा, 3 पे जाना होगा या 4 पे जाना होगा, तब जाके इसमें से किसी पाथ पे, यहाँ के किसी पाथ को मैं चूज करके 5 पे जा सकता हूँ।
Okay, got it.
इंटरमीडिएटरी।
पहले वाले में हम डायरेक्ट ले लेते थे, इसमें हमने डायरेक्ट नहीं ले रहे, है ना?
राइट, you need some intermediate results to reach 2 3 4 before reaching 5. This is the case. Now tell me, what is the doubt you are having today?
No.
तुम्हारा हो गया, तुम तो समझ गए, बाकी what doubts you are having? Go through the video once more. Go through the video once more, you will get more clarity. एक दिन की चीज डायनेमिक प्रोग्रामिंग नहीं है, okay? Nobody can learn dynamic programming in one day. Believe me this. I too still learn techniques. और ये तो बहुत बेसिक लेवल का डीपी हुआ. This is the basic level of DP. You will get more using tree plus DP problems. Okay, there are many problems. Okay, that okay, I am utilizing an array now. I will utilize a tree for solving DP problems. Such kind of techniques you will find. So, okay, go through this once more, all the videos. Perhaps I may require another class to complete the DP part. Okay, एक क्लास 2 क्लास में तो बहुत कम होता है भाई, डीपी में हफ्ता गुजर जाता है सही से पढ़े तो. Shall I wrap it up for today?
Yes.
और पढ़ना है?
सर ये तो समझ में आ रहा है, आप कोड कर दिए, लेकिन हम लोग उसको कैसे डिफाइन करेंगे कि हम ऐसे ही कर
ऑब्जर्वेशन,
सकते।
तुमको मैं ऑब्जर्वेशन आज बताया ना क्या हो रहा है
जो
देखो।
आप स्पेस दे रहे हैं ना, तो
हम्म।
स्पेस हम कैसे कंसिडर करेंगे कि इतना ही हमको
कंसिडर,
डालना है करके?
जैसा तुम्हें बताया क्वेश्चन को देखना पड़ेगा, क्वेश्चन क्या कह रहा है। इस क्वेश्चन में तो था चलो मैं 0 से स्टार्ट करूंगा, 1 पे जाऊंगा, 2 पे जाऊंगा, 3 पे जाऊंगा। तुम्हें ऐसे ऑब्जर्वेशन फ्रेम करना पड़ेगा कि हो क्या रहा है क्वेश्चंस में। दिस इज वेरी नेसेसरी, मैं जो तुम्हें दिखा रहा हूँ ये बहुत नेसेसरी है प्रॉब्लम सॉल्विंग के लिए। मैं देखो, आई एम नॉट हेयर टू मेमोराइज यू समथिंग, ये मैं नहीं करने वाला कि तुमको 2 दिन में क्वेश्चंस रटवा के बोलूंगा जाओ इंटरव्यू दो।
नहीं, ऐसा तो कभी होता नहीं है सर।
ठीक है, तो मैं
सर ये
ठीक।
बॉटम अप्रोच समझ नहीं आया ढंग से। सर ये फिबोनाची सीरीज में भी पॉसिबल है।
हाँ फिबोनाची सीरीज
बट
में भी पॉसिबल है, बिल्कुल
सर,
पॉसिबल है।
सर एक बार उससे समझाना आप कल की क्लास में।
ठीक है कल
इससे
तो
थोड़ा
डाउट,
कॉम्प्लिकेटेड था।
डाउट क्लास में आओ कल बताते हैं, ठीक है।
ओके सर।
कल तो डाउट क्लास है ना।
यस सर।
ठीक है, कल कुछ और प्रॉब्लम्स भी लेना पड़ेगा।
सर
हाँ बोलो।
मैंने एक सजेशन लेना है आपसे।
बोलो।
कोई बुक आप रेफर कर सकते हो, जैसे डिजेंगो, जहाँ मतलब जो बेसिक पाइथन ना हो, अपना उसके लिए।
तो मैं भी नहीं पढ़ा भाई आज तक कभी, यही बात
अरे
है।
यार, एआई
क्या
वगैरह के
किसके
लिए,
लिए चाहिए
एआई
किस?
एमएल के लिए नहीं है आपके पास कोई रेफरेंस है?
नहीं AIML तो चलो मुझे भी नहीं आती भाई, मैं
अरे
तुम्हें क्या
यार,
बताऊंगा।
अरे, इसका तो फायदा ही नहीं है जो फिर पढ़ रहे हैं हम।
पर AIML बहुत वास्ट चीज है, मतलब दूसरी ही चीज है जो तुम चाहते हो, यहाँ से तो कोई ताल्लुक ही
पाइथन,
नहीं है।
पाइथन, सिंपल पाइथन की बेस पे नौकरी मिलती है।
मिलती है
अच्छा।
अभी तो और। अरे भाई तुम जा रहे हो, ये जो चीज लगेगा ये तुम्हारे इंटरव्यू क्लियर करने के लिए काम आएगा। फिर मेन जो तुम जाओगे फुल स्टैक रोल पे जाओगे।
बट मेरा मानना सर थोड़ा सा ये है कि मतलब अभी तो फुल स्टैक की वैल्यू है, लेकिन आज से 6-7 साल बाद का फ्यूचर देखें तो मेरे को लगता है बिकॉज स्टैक्स चेंज होते रहते हैं, ट्रेंड चेंज होता रहता है। पहले एसक्यूएल का था, अभी मोंगोडीबी है अपना, तो लोग थोड़े फैंसी से बनते जा रहे हैं
अरे वो
कंसेप्ट।
बात नहीं है, बात तुम बात तो SQL और यूज नहीं होता आजकल, आज भी तो यूज होता है, ऐसा थोड़ी
बट
ना है।
अब इंडियन ट्रेंड में देखें ना तो
वो
लोग अगर,
तो इंडियन में तो मैक्सिमम फॉरेन की कंपनीज है, अगर उस हिसाब से चलेंगे तो।
नहीं एसक्यूएल वर्ल्ड लेवल पे देखते हैं ना तो जो होता है यूज, लेकिन लोग अभी नो एसक्यूएल ही चलने लग गया है।
तो तुम एक बड़ी कंपनी का नाम बताओ जहाँ पे SQL का यूज नहीं होता। ऐसा नहीं है कि SQL नो SQL के आने से SQL खत्म हो गया, SQL
खत्म
भी
नहीं हुआ।
यूज होता है, नो SQL भी यूज होता है, हर
मैं
जगह है
सर
ये।
अभी का ट्रेंड नहीं बता रहा, मैं आने वाला ट्रेंड बता रहा हूँ।
जो देखते हैं चलो फॉर द फ्यूचर में, तो फिर पता लगेगा कंपनी क्या करती है कोई भी। चलो MCQ हैव स्टार्टेड, अटेम्प्ट ऑल ऑफ यू। The questions I have given, Okay, I have created the attendance also. Those who are not having any doubt, please mark your attendance. And if you're having any doubt, you can stay back. सौरभ चला गया क्या?
नहीं सर,
बताओ जनाब, क्या हाल है?
सब बढ़िया है।
एंड ये तुम्हारे रीटेस्ट के रिजल्ट्स का क्या हुआ? कब आएंगे, कुछ मालूम है?
आज आने वाला था बट पता नहीं चला कुछ।
आज तो डिक्लेयर हो गया होगा सर।
डिक्लेयर
आज डिक्लेयर हो गया होगा।
तो कहाँ पे कुछ मालूम है, मतलब कहाँ पे आता है ये, समथिंग लाइक दैट?
हम
वो तो
लोगों को
सबका यूजर पोर्टल में रहता है ना सर, हर किसी का।
इंडिविजुअली दिखता है।
ओके ओके।
वही तो प्रॉब्लम है ना कि ये लोग पूरा रिजल्ट डिक्लेयर नहीं करते कि कौन कितना क्या किया है।
छुपाते हैं भाई, कितने लोग रिटेस्ट भी दिए वो भी छुपाते हैं।
कुछ
क्लास का स्ट्रेंथ ऑलरेडी बहुत, मतलब कम लोग अटेंड करते हैं आजकल, तो मैं यही देखता हूँ।
पहले
नहीं
47
सर,
का क्लास हुआ करता था
ना, अभी भी स्ट्रेंथ तुम्हारे क्लास का 49 ही है, 49 50 के अराउंड, शायद 49 है जितना मैं जानता हूँ। आते नहीं है कोई और, वर्किंग प्रोफेशनल्स वगैरह होंगे शायद, टाइम नहीं मिल रहा होगा।
फिर तो अटेंडेंस का क्राइटेरिया कैसे
मेरे
फुलफिल
को
होगा?
आई डोंट नो, कुछ बात है तो मेरे को नहीं मालूम।
पता नहीं, देखा जाएगा।
चलो, तुम्हारा एग्जाम है ना नेक्स्ट वीक?
हाँ शायद 30 को रहेगा।
चलो, डीपी में तो चलो इंक्लूड नहीं कर
27 को आ जाएगा भाई, 27 को सैटरडे है।
27 का है क्या? तो फिर
हाँ
भी
सैटरडे 27 को है।
27
तो
को।
वे लोग नॉर्मली 20 सैटरडे को ही करते हैं ना।
चलो, मैं
हाँ
कह दूंगा कि डीपी ना इंक्लूड करे इस बार।
हाँ
नहीं,
सर,
डीपी मत,
क्योंकि
डीपी ना
इसको
करे तो ज्यादा
इसको
बेटर।
सर समझने के लिए बहुत टाइम लगेगा।
तो पढ़ाई नहीं, प्रैक्टिस लगेगा। प्रैक्टिस करो, जो जो सीसी वगैरह में आ रहा है उसको अच्छे से प्रैक्टिस करो।
जी सर। सर आज का जो सीसी दिए है ना, हाँ
एक तो
उसमें सर
फिबोनाची
आपने,
रिलेटेड है।
हाँ केत केत जो बताया है कि निकालने के लिए, तो उसको
कौन
तो
सा?
सर एरे में तो हो जाता है ना वो, उसको हम इस टाइप वगैरह करना पड़ेगा क्या?
कौन सा?
मैं सर वो क्वेश्चन बता रहा हूँ। kth लार्जेस्ट एलिमेंट इन एन एरे।
तो वो तो हीप
उसको,
का रिलेटेड प्रॉब्लम है ना।
अच्छा उसको हीप यूज करना है सर।
हाँ, हीप यूज करना है।
नहीं तो इसे एरे में करेंगे तो 2-3 लाइन में तो
एन
काम
लॉग एन
खत्म हो
आएगा,
जाता है।
एन लॉग एन का आएगा कॉम्प्लेक्सिटी।
हाँ हाँ
सर जो
जी।
आपने बताया था कि 3 एलिमेंट्स होने चाहिए एक लूप में, वैसे करना है एक हीप में?
समझा नहीं, फिर बताओ।
सर
हाँ हाँ
आपने
हाँ,
ये बताया था।
के है, अगर के एलिमेंट निकालना है तो के साइज का हीप बनाना पड़ेगा, ठीक है। कोड भी तो शायद बता दिया था उसी दिन, राइट?
सर बता दिया था, बस वैसे ही करना है फिर।
वैसे ही करना है। ये मामूली क्वेश्चन नहीं है, सोचना ये बहुत इंपॉर्टेंट क्वेश्चन है इंटरव्यू पॉइंट ऑफ व्यू से, ठीक है। और उसका एक वेरिएशन है, देखो कि एक ये अनलिमिटेड स्ट्रीम ऑफ नंबर्स आ रहा है, तो उसका मुझे एट एवरी पॉइंट में भी केथ स्मॉलेस्ट नंबर बताना पड़ेगा या केथ लार्जेस्ट नंबर बताना पड़ेगा। तो ये भी सिमिलर हीप से ही बनेगा आई थिंक। ये अनलिमिटेड स्ट्रीम का मैंने तुम्हें क्यू से दिखाया था ना एक प्रॉब्लम, कि हर पॉइंट पे तुम्हें प्रिंट करना
सर
पड़ेगा।
वो
So first
तो ज्यादा
non-repeated
डिफिकल्ट लग रहा है सेकंड
number.
वाला
कौन सा?
फिर क्वेश्चन था आपने क्यू और हैशिंग को यूज
हैशिंग
करके
से, हाँ, यूज करके।
कि एक नंबर है फर्स्ट नॉन रिपीटिंग को प्रिंट करना था।
लोग को हैशिंग का कुछ कुछ इंपॉर्टेंट प्रॉब्लम अभी मैं बता नहीं पाया हूँ, जो बेसिक प्रॉब्लम है बट थोड़ा जरूरी होता है, बिकॉज टाइम नहीं है। यही बात है, नेक्स्ट वीक तुम लोग का स्टार्ट हो जाएगा ऑपरेटिंग सिस्टम्स एंड ऑल, और एक दो मई वीक होगा, सो आई विल बी हैविंग सम सैटरडेज विद यू, जिसमें और थोड़ा प्रॉब्लम्स डिस्कस कर सकते हैं, ठीक है। तुम लोगों को कौन कौन से टॉपिक का मोर प्रॉब्लम्स चाहिए ये मुझे बता देना बिफोर वी आर जंपिंग टू द कोर सीएसई पार्ट।
ओके सर।
जी सर।
ठीक है। देयर विल बी वन मोर टॉपिक दैट इज बैक ट्रैकिंग। रिकर्शन किया है ना, बैक ट्रैकिंग आएगा अब कुछ दिनों बाद। मत समझना कि वो भी आसान है। आफ्टर मैं बोलता हूँ ना, मैंने कहा था ना लिंक लिस्ट ट्रांजिशन पॉइंट है। कुछ भी आसान लगा लिंक लिस्ट से? बताओ मुझे एक बात बताओ।
कुछ भी नहीं।
कहा था ना मैंने, ट्रांजिशन पॉइंट है, यही होता है।
एक
अगर
एक
कोई
कन,
देखो
एक
माइंड
कंसेप्ट
से,
और
बोलो।
एक्सेप्शन हैंडलिंग पढ़ना था।
यस, एक्सेप्शन हैंडलिंग, राइट। अच्छा ठीक है, वो भी किसी सैटरडे को मैं बता दूंगा। एक्सेप्शन हैंडलिंग एज वेल एज पैकेज मेकिंग, ये दो टॉपिक है जो मैं बता दूंगा मैं, ठीक है। किसी फ्राइडे को सिलेक्ट करना पड़ेगा, सैटरडे को,
क्योंकि बहुत जगह एक्सेप्शन हैंडलिंग लगेगा।
ऊप्स के भी और भी, बट और कॉन्सेप्ट और क्या है ऊप्स का कुछ बचा है अच्छे से बताने के लिए?
एक एक्सेप्शन दिखा मुझे, और
एक्सेप्शन
मैं
ऊप्स में नहीं आता, कहीं और आता है।
ओके।
ठीक है, चलो ठीक। और भी है। तुम्हारा रिजल्ट कहाँ पर है भाई? ये तो मैं देखना चाहता हूँ, वेयर इज द रिजल्ट। और इस बार भी बैच चेंज आ रहा है बहुतों का।
क्या सर?
सर जो एक्सेप्शन वगैरह बताया वो फाइल हैंडलिंग में आता है ना?
नहीं, फाइल हैंडलिंग में नहीं आता, वो कहीं भी आ सकता है, ठीक है। फाइल हैंडलिंग में मतलब
और
these are the very important topics for handling those things.
फाइल हैंडलिंग में सीएसवी वगैरह आएगा।
फाइल
CSV
हैंडलिंग है
फाइल
तुम लोग का? फाइल हैंडलिंग तो नहीं है शायद, जाओगे तो पता
नहीं
लगेगा।
सर।
और यहाँ पे
सर
तुम्हारा
एक बार थोड़ा बता देते तो अच्छा होता ना हम लोग को।
फुल स्टैक में आएगा, ये तुम लोग को मिलेगा वहाँ पे, क्योंकि पाइथन में बताया कोई फायदा नहीं है। क्या वो तो पाइथन तुम्हारे बैक एंड फ्रंट एंड में यूज होगा ही नहीं, इसीलिए बोल रहा हूँ। वहाँ पे तुमको
अच्छा
बताएंगे
फिर
अच्छे
आगे
से।
जाके वही जावास्क्रिप्ट और एचटीएमएल ही।
HTML CSS JS आएगा, और रिएक्ट आएगा उसके बाद, ठीक है। और नोड JS आएगा प्रोबेबली।
वो भी लिंक लिस्ट जैसा ही है।
नहीं, लिंक लिस्ट नहीं, नोड
नहीं,
JS।
मींस टफनेस।
टफनेस तो सब कुछ ही नया होगा, और मोर टफ जब जावास्क्रिप्ट तो नॉर्मल लैंग्वेजेस है, नया नया फीचर्स आएगा, सब सीखोगे। दोज थिंग्स आर क्वाइट अनरिलेटेड, जो भी कर रहे हो वो बहुत अनरिलेटेड थिंग मिलेगा वहां पे। बट यस, सब कुछ नया होगा। HTML CSS तक तो आसान होगा, बट वंस रिएक्ट विल बी कमिंग, दोज थिंग्स टफ होने लगेगा धीरे धीरे। इस माइंडसेट से ना चलो कि मुझे सब कुछ आसान मिलेगा, मैं एक दिन में समझ जाऊंगा, ऐसा नहीं होता है। इसीलिए कहता हूँ प्रैक्टिस मोर, प्रैक्टिस मोर। और कोई भी डीएस एल्गो का प्रैक्टिस इवन आफ्टर द क्लासेस नहीं छोड़ेगा। मैं तो, और कोई भी प्रॉब्लम होगा, आई थिंक आप सबके पास मेरा नंबर है, मुझे पूछ सकते हो एट एनी पॉइंट, ठीक है। इवन इफ यू आर गेटिंग प्लेस्ड, डेफिनेटली प्लेसमेंट तो हो गई कहीं ना कहीं पे, इवन आफ्टर प्लेसमेंट भी कोई प्रैक्टिस नहीं छोड़ेगा। वीकेंड्स पे करना, कभी भी टाइम फ्री मिले तो करना, पर करना पड़ेगा अगर अपने फ्यूचर को भी और बेटर बनाना चाहते हो तो।
ओके।
ओके, अभी बहुत, अभी तो सिर्फ शुरुआत है बॉस, आगे अभी और भी है, मैं क्या बताऊं। चलो सही, मैंने अप्रिशिएशन आप सबको मेरी तरफ से कि भाई इतनी जल्दी इतना कुछ टेकअप किया है, ये बात है। वो भी नॉन कोडिंग बैकग्राउंड से आके, नहीं तो शायद मैं भी नहीं कर पाता कभी, ये बात तो मैं गारंटी देता हूँ। मुझे सीखने में बहुत दिन लगा था सारी चीजें, जबकि भी मैं बहुत दिन से कोडिंग बैकग्राउंड में था, क्लास 11 से अपने। दैट्स द थिंग। चलो, आप लोगों ने बहुत अच्छा किया, बहुत जल्दी में, दैट्स द ट्रुथ। वो भी शायद बहुत लोग, आप लोग वर्किंग प्रोफेशनल्स हो यहाँ पे, डिफरेंट डिफरेंट बैकग्राउंड से आए हो, कोई इसी डिपार्टमेंट से आया है, तो सीएस का है, सीएस के बहुत कम लोग हैं मुझे लगता है यहाँ पे, राइट? मेरे
एक भी
बैच में
नहीं है।
सबसे, क्या बात कर रहे हो?
एक भी नहीं है सीएस बैकग्राउंड से।
तो सच्ची में बैच बहुत अच्छा है, आई मस्ट से, बैच रियली में बहुत अच्छा है मुझे जो मिला है, जो क्योंकि इतनी जल्दी आप सीख कैसे गए, पॉइंट तो आएगा ना। आह, कोई नहीं सीख पाता यार। और देखो पहली बार देख रहे हो, टाइम कम, टफ तो लगेगा ही, बट पेस एंड मोर रिव्यू ऑफ थिंग्स, ये थिंग्स इजी हो जाएगा, डोंट वरी ऑन दैट। चलो सही, ठीक, चलो गुड नाइट ऑल ऑफ यू।
एक 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 चैट बॉक्स में मैसेज किया।
अच्छा ठीक है, अभी कर रहे हो या फिर कर दिया है?
कर दिया कर दिया।
ठीक है, मिल गया। चलो सही, गुड नाइट ऑल ऑफ यू। देखो
गुड नाइट।
मैं तो रास्ता दिखा सकता हूँ, बट मेहनत तुम लोग ने बहुत की है, इसमें कोई बात नहीं है। ठीक,
डर
2 ही 3
डर डर लग रहा था कि असाइनमेंट अगर नहीं सबमिट करेंगे, सीसी नहीं सबमिट करेंगे तो स्कोर डाउन होगा, उस चक्कर में हम लोगों ने मेहनत कर ली।
चलो
ये एक्चुअल पॉइंट।
एकदम एकदम सही बोले भाई।
हाँ
ये सौरभ भाई जो बताए एकदम सही बताए।
चलो, किसी भी तरीके से किया ना, यही तो बात है, बहुत ज्यादा किया रादर, 2-3 महीना में बहुत ज्यादा सीख गए, ये तो मैं
जो
बोलूंगा ही।
जो कंसेप्ट नहीं समझता था
हम्म,
उसका यूट्यूब पे लेक्चर देखते हैं हम लोग।
जरूरी भी है टू एन एक्सटेंट, बहुत जरूरी है।
और फिर उसके बाद में हम लोग अलग से दिमाग लगा के फिर करते हैं,
हम्म,
तो और ज्यादा क्लियर हो जाता है।
चलो सही, बहुत
दूसरा,
अच्छे।
इंटरव्यू पॉइंट ऑफ व्यू से जो आंसर्स करने हैं, कैसे आंसर्स करने हैं, वो भी बहुत ज्यादा क्लियर हो जाते हैं यूट्यूब वीडियोस में।
हम्म, चलो बहुत बढ़िया, करते रहो प्रैक्टिस, यही बात।
गुड नाइट सर।
गुड नाइट, हाँ ऑल ऑफ यू।
गुड नाइट सर।
गुड नाइट।